These, of course, here are my water fuel cells here, and you'll see these connector pieces that I have on those little pieces of stainless steel. It's 4mm stainless steel dental strip, matter of fact, that I use. But I've had some connectivity issues and just wanted to kind of design a better one here. See, the other one got mashed up here. In new versions here, we have it, let's say, kind of like folded over the edge right there, as you can see, and hopefully that will allow a much more consistent connection for the terminals that I have in this base piece here. These are stainless steel hex bolts, I guess, going through here, and these are just kind of some 3D printed covers for the nuts that are on the bolt there, maybe to help reduce the actual exposure to the water bath, decreasing electrons being released into the water, shorting out things like that. The idea is we only want the water to be essentially exposed in between these two stainless steel tubes. Anything else is going to be inefficiencies introduced into the system. So that covers up most of that. And with this new kind of system here, which I've kind of redesigned here, we've got the stainless steel kind of folded over into this little crevice here that keeps it in place, keeps it from getting out of place and mashed up, let's say, like that one is or whatever. So made some other minor improvements here with tolerances, adjustments for the new Bambu Lab printer I have, printing at a much higher resolution and quality, and just some overall improvements to the design of these water fuel cells here. And you can see here kind of all stacked together. I'll unhide all here. You can see kind of a triple stack plate here for the enclosures. So we're gonna print out some more. We're awaiting some ABS filament because PLA will deteriorate in water. So once we get the ABS and print these things out, we're going to basically redo all these cells, as well as we got some new tubes going to be ordered here soon, with a slightly bigger gap in between those tubes, so slightly thinner outer tube to introduce more gap in between here, which would essentially be more resistance, which should allow for a higher voltage level, and just to see how these will perform in comparison. So a lot coming up here.
Welcome to Season 4 of Stan's Revenge. A new exciting chapter awaits. My name is Noah Almond. I've been experimenting with Stanley Meyer's water fuel cell technology for over 14 years. In previous seasons, I've made exciting discoveries in its technology, namely the operation of the electrical polarization process. This is unlike traditional DC electrolysis, where low voltage and high amperage is utilized. As always, no electrolyte or additives are used in my cells. Only ordinary, natural water is utilized. In this season, I pushed the boundaries of my water fuel cell technology further in my latest attempt to break the glass ceiling of 150 volts. Join me as we unlock the secrets. This is Stan's Revenge.
A little more detail and reference here. We have these slots in the middle here for the stainless steel to kind of protrude through to where we bend it so it makes good contact to the inside of that inner tube. And then these slots on the outside here, so you'll see that stainless steel protruding out right here to make contact with the outermost tube here. So in spectacular fashion here, we've got this guy right here, which slides right into there. The outer tube slides nicely into there. Makes great contact. And I'm going to modify these just a little bit further to where that metal is sticking up a little bit further. We have more contact to those metal pins. I redesigned these end caps for my water fuel cells just to basically adjust for the new 3D printer I have, which has a lot higher tolerance, and just print these with a much higher tolerance, adjusting some settings here, as I'll maybe show in another video. We still have a lot of this metal exposed on the bottom, and we're going to be changing that to where there's no exposed metal where it doesn't need to be, reducing or increasing efficiency rather. And then also the diameter of these holes here, making sure that these are as precise as possible and as little variance in these as possible. This wonderful annoying beep you here is actually great. Got a new printout here of these basically cell bases. We've got a just a resistance meter here. The tone is basically for connection. So we've got these two little prongs through here. And inherently, I may have showed you previously of these connections here just getting all mashed up and whatnot. I've inserted these things probably 3 dozen times now and get solid connection, even with my 2 cables, less than 2 ohms. And just by placing this thing in here, you'll see just instant connection. Bam, just not even really pressing it in there, but fully inserted. I can move this thing around and I just have a perfect connection every time, no matter how many times I insert this to the device. So 1,000 times more reliable connection here with these new kind of connector pieces on it. I've refined the actual sizing of this as well, so the tolerances are much lower. There's much less metal exposed that should not be exposed. I do believe that majority of my problem here with my cells, which I may show you, is that these connections just get all kind of marred up and don't have much springiness to them and just do not want to stay connected, giving me higher resistance, etc. Additionally, on this 4mm dental strip, it's key that we use the shiny edges or ends of this, the shiny side rather, because the side that has the I guess diamond bit, whatever, polishing on it, definitely reduces connectivity on it. So either by scraping that off or using the tips of it, which should be bare steel without any let's say sandpaper-esque type material on it, will provide the best connection here. So we just have to rebuild all these cells with these new connections here. I'm going to print out a whole batch of these, and then we're going to have a whole new batch of new cells where my financiers have agreed to basically provide me with a bunch of new tubing. We're going to do different tubing with different gaps, a bigger gap on it. Perhaps even longer tubes as well, to see if we can get more production per unit on here, see how that affects capacitance, overall circuit performance, etc. But I do believe the reason why I've been having such terrible performance here since kind of putting this all back together is the fact that my cells just are not connecting very good in there, and it's just extremely high resistance and poor connection. So with these, we're hopefully going to have that problem solved. So gotta wait for these this 4mm dental strip. I'm gonna say that again. 4mm dental strip to come in. We're gonna basically reinsert all the as you can see there, that metal strip. Let me try to do it. Bam, coming out the side there. And we kind of redesigned these two, so they're just gonna be a much more snug connection without deforming the actual tolerance of these at all. My new Bambu Labs Carbon X1 prints these out so much more immaculate than what the Ender 3 could ever dream of. So I think these here are done with the Ender 3, and just quality is not what these are here. Still printing in ABS, And you can see just we have a much finer print here. Can't wait to get these puppies installed. We are going to be back in action here. Got a lot of cool stuff I'm going to be trying here. Welcome to Stan's Revenge. We are going to be making some progress. Stay tuned.
This is Stan's Revenge.